So Carly, where are we today?
Yeah, so we are at the Australian Telescope Compact Array. This is a radio telescope and we are here in Narrabri, New South Wales.
We were just at a telescope, so we're at Parkes Radio Telescope, and there was just one big single dish there, but I'm looking behind us now and there's like 4 or 5 dishes, so what's going on here?
Yeah, so this is a slightly different type of radio telescope. It's what we call interferometry. So we basically get a bunch of dishes. This compact array has 6 separate dishes that all combine to create one giant telescope.
How big of a telescope do these combine to give us?
Yeah, so the maximum distance between 2 of these telescopes, 2 of these dishes, is 6 kilometers. So that mimics a telescope that is 6 kilometers wide.
6 kilometers, so the Parkes Radio Telescope was 64 meters, so 6 kilometers, that's like 100 times the size. What's the advantage that gives us?
Yeah, so it is a lot bigger, and basically the bigger the telescope, the more light or the more radio waves we can detect, which gives us a higher resolution image. We just get much better quality images.
Okay, so if we're getting better quality images from a large array like this, what is the point of having a single dish telescope like Parkes?
That is a great question, Pete. Absolutely. So there is a difference between, say, a single dish like Parkes and the compact array behind us. The single dish is really, really good at picking up the more extended details, whereas the interferometers, they're much better at picking up that really fine detail. So if we're looking at an object that is, say, a bit fluffy, a bit cloudy, really extended in its size, they're really good for single dishes. But if we're looking at an object and it's quite compact, then these telescopes, the interferometers, are perfect for that. The best case scenario is to combine both telescopes.
Okay, so we know that the big telescopes like this are really good at that fine detail, and the single dish telescopes are really good at picking up larger things. So why don't we just make one big 6 kilometer single dish?
I like your optimism there. But unfortunately, we have this little thing called gravity on Earth. Now, we saw back in 2020 the catastrophic effects of gravity when the Arecibo telescope unfortunately collapsed. Now, the Arecibo telescope was 300 meters wide. This is one of the largest single dish telescopes we've ever seen in history. But unfortunately, we see gravity is going against us here and we just can't make them that big. And that's why interferometry combined with single dish is currently our best solution.
Yeah, so let's go have a look around.
Yeah, let's get it.